So I will present now the methods and models session, and I'm going to present a review of models and methods used in decision support systems that we did within the forces cost action. And this is a review that we have been doing between several authors, so I acknowledge them here. So this is the outline of my presentation. So first, I will give a short motivation of this work, then a bit of background, the methodology, results, and the link with the community of practice. So basically, as I said, this work has been done in the framework of the cost action forces, and now it will continue within the community of practice. So you can check the web pages of these two, of the cost action and the community of practice. So basically, the motivation of this work was that there is no centralized repository of methods and models used to address forest planning problems. And so there is a lot of literature out there, but there is not a centralized repository. And then there is no information of which models have been implemented in decision support systems. And also, we are interested in knowing if the methods developed in research if they have been introduced in decision support systems, and also if they have been used in practice. So we are interested in knowing if they are used, okay, and if they are used, if they are good methods, or if they have some constraints, and also if they have not been used, we are interested in knowing why. So why a method that it has been developed, why it's not used, or so basically the approach that we are following, it's a problem-oriented approach. So we know that there are planning problems, and then so when you are facing a planning problem, then we know that some methods have been developed to address them, and we want to know which ones they have been implemented in decision support systems. So about the methods, there are several classifications that we can do, but basically we did this simple one. So we classified the methods in optimization methods, either heuristics or classic, then multi-criteria methods, and then simulation or what-if analysis, or called also here assessment. As I said, this is a problem-oriented approach, so within forces, we develop these dimensions. So the forestry problems, they can be classified based on these dimensions. So first of all, there is the spatial context. So one problem can be spatial with neighborhood interrelations. It means that the decisions that you are making in one stand, they will have an impact in other stands. So if this relation between the neighbor stands is important for the problem, this is a spatial with neighborhood interrelations planning problem. So the second, the spatial with no neighborhood interrelations, is when you are interested in keeping the integrality of the stand. So the decisions that you make, they will be applied to the whole stand. So you cannot divide the stand in small pieces. But you are not really taking into account the interrelations between neighboring stands. And then the third one, it's non-spatial. It means that you can divide the stands, or you can aggregate them in stratums and treat them all together. So now there is the spatial scale, so it can be a stand level planning problem, or it can be a forest level planning problem, or regional or national. So it's divided in this stand level or forest regional. Then there is the dimension of the decision making. So if there is a single decision maker, or if there is one or more decision makers. The objectives, so if you have a single objective, for example, your objective is producing as much timber as possible, and you don't really care about the other products. And then multiple. When you in your planning problem, you are addressing multiple objectives like timber production and biodiversity and others. And then the goods and services, like when you are taking non-wood forest products into account, for example. So basically, each combination of all these dimensions, for us, it's a problem type. So you may have a problem like a spatial with neighborhood interrelations at a regional level with one single decision maker and single objective and not taking into account other goods and services. And here in the wiki of the cost action, you can see the description of this spatial, of these dimensions and the approach that we followed. So basically in this review, the material, there is a lot of material available. So within the cost action, we had the country reports, and these country reports were like making a review of all the decision support systems that have been developed in different countries and the planning problems that they addressed. So there are also scientific journals that with the models and methods that have been developed and decision support systems. And then also we have the wiki. But in our case, we decided to focus our review only in scientific publications. So basically we proceed to do the search, and we used some keywords. And in this case, our search was to do the search, we use the forest support system or forest decision support system keyword. So after doing this search, we got like 2,000, more or less 2,000 articles, and we focused our search in the last 12 years, so from 2000 to 2012. So we got 2,000 articles, and we analyzed the problem types addressed in these articles. So first we did the screening of these 2,000 articles, and then we checked if they had models and methods there, and if these models and methods were implemented in decision support systems. And we did this problem type approach. So we analyzed which problem types were addressed in these articles, and then we did the whole analyze. So basically we found 94 publications that were analyzed more in depth, and then this is the distribution of these publications over years, and then you can see this peak here between 2004 and 2007, and this was because there were several special issues about decision support systems and models. So if we analyze from these 94 publications, like the distribution among the dimensions, so you can see that, well, there is an more or less even distribution in the spatial context. There are 29 articles dealing with spatial with neighborhood interrelations, 35 with no neighborhood interrelation, and 13 non-spatial. So most of the articles were addressing forest regional or national level planning problems, and most of them they address single decision maker problems. And as you can see, 70 of the 94 were addressing multiple objective planning problems. And so if we analyze as I said, a problem type, it's a combination of these all dimensions. And if we try to analyze how many, so these numbers mean that 20 articles were addressing spatial with no neighborhood interrelations at forest level and with a single decision maker. The second, here, 19 articles were dealing with spatial with neighborhood interrelations, forest level, and 19 single decision maker. So, and here at the end of the table, only one article was dealing with a spatial neighborhood with at forest level, one decision maker, and more. This is, I'm not sure. Okay. So about the methods, so 12 articles deal with address the planning problems with heuristics, 25 with classical optimization methods, 24 used multi-criteria, and 33 used simulation or assessment. And here is just to show you the most common problem types. So here you can see this 20 here in the left means that 20 articles were addressing this spatial, forest region. So, and here are the methods that have been used to address this problem. So this here and here. So there are 3 different blocks, and this problem here, they are dealing with, they are mostly using multi-criteria because they are addressing multi-objective forest planning problems. So out of this review, we have some lessons learned. So at forest level, there are a lot of articles using simulation only. And also there are other articles that they are using classic optimization. Linear programming is the method used mostly when no-neighborhood interrelations are addressed. Then there are several articles using mixed integer programming. And heuristics have been used for both, even when no-neighborhood interrelations have been used. So at the stand level, there are few articles that used optimization. Most of them are using simulation. And then when there are 2 or more decision makers involved, well, they have been using multi-criteria analysis, and now there are several articles coming out from using Pareto frontier methods. And about risk, we found out that most of the articles are using simulation only, but now there are also stochastic models and optimization being used. So there is some research going on. For example, there have been some articles dealing with fine-tuning current approaches to address risk. So some other articles are addressing uncertainty related to the preferences of the of the decision makers. And there are other approaches to address risk and uncertainty. For example, stochastic optimization models. And then the relation with the community of practice. So in this community of practice, we have the objective to make a repository of the methods and models developed to address forest problems. So it will be a repository not only on the methods and models used, but also we will describe if the models and methods have been integrated in decision support systems, and also we would like to have information on how good these models and methods are and if they are used in real problems. And for this we will use the wiki, so proper forms are being designed to introduce this information in the wiki. And we would like to have a continuous update of these decision support systems and models and methods. So we encourage the people to participate and to go to the wiki and to add information. And then the acknowledgements to this project, the cost action, the community of practice, and ForestDSS. Yeah. So thank you.